Okay, we're live. Okay, so I opened the homework and started working on some of it a bit earlier, just to kind of look through some of the questions, but I don't know. The lesson, I was just looking through the wiki that they gave us, and there wasn't a whole lot there that I see. So some of the questions, I was having a hard time with this section.
Not making very much sense.
Yeah, so like I said, the lesson, there was over half the lesson was just kind of the example. It's like, oh, here's the example. Now here's how all that stuff, here's what it means. And there's about, maybe just a bunch of short paragraphs. And all right, there you go. I'm like, oh.
Yeah. It's more just teach you how to read. So yeah. Let's see what we can clear it out. Basically, you just need to understand the symbol, what it means. Like the little U thing and a little N thing.
Mm-hmm.
O thing. I don't know how to pronounce that in Latin language.
Yeah.
But yeah, key. And if you understand what that means, that's basically what you need.
Yeah. So what's what is the U then? Maybe that's what's throwing me off then. Because you have the O thing, the Latin Greek O thing. You have the U, the funny looking U, and then you just have
Yeah.
I know the X with the line over it stands for the mean.
Yeah, so basically, here's you see if you plug the Wikipedia, whatever that is, there's number 4. So here it explained when is X means normal. If the parent is a parent population that a sample distribution X is normal. Yeah. Let's see. Take action. The mean of sample mean is this U symbol, and the standard deviation of the sample mean.
I thought the U was mu. It looks like from what I'm looking, it looks like it says that's the mean of the population. So the X is the mean of the X with the X with the line over it, or the X bar. That's the mean of the sample, and then the funny looking U, I'll call it U, is the mean of the population. So one's the population mean, and one's this this mean of the sample.
Okay.
And then the O, funny looking O, is sigma, and that represents the standard deviation of the population.
Yes.
Okay.
Like the statistic, standard deviation of the statistic that we take, basically.
Of population. Okay. And then you have the sigma summation, which is the funny looking E. But the funny O is the lowercase sigma. Okay. Nice. So I would pull up the homework pulled up, so I can start with there.
Yeah. See the summary page on the textbook, online textbook. Number 7 is summary. Meanings.
Okay, so lesson 6. Okay, 1 and 2 are true. Okay. Okay, question number 3. So when you're taking a sample size of n, so what is it?
Parent population, it means the sample size you take from.
The sample size, okay.
Okay. The data pile you grab from.
Okay. So if we have sample size of 5, what that's saying. So if we have sample size of 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
I think I just read something about this.
So I know it talked about briefly in the reading, I know it talked about like even if something's skewed right, the normal distribution, whatever we call it, of the they're stupid. So many different means and deviations, and it gets confusing. But where your distribution means it's based off of your sample distribution. And so if one of them, even if you have one that's skewed right, sample of that distribution, you can like a sample of the sample. And if you take a large enough sample of the sample, it'll still be a normal distribution. But since our sample size is only 5, and the parent population, so what we took from the original thing that we took it from is already skewed right.
Yeah, so it should be skewed right.
That's what I'm thinking, yeah.
When you're taking sample size of 900, what is the shape of distribution of means when parent population is skewed right? I say normal.
It could be normal, yeah.
That's what the definition says on here. Let me read to you.
Okay.
Here, there are 2 situations when the distribution of x over line is generally to be normal. First, if the parent population is normal. Second, even if the parent population is not normal, the central limit theorem guarantees that distribution of sample will be approximately normal if the sample size n is large enough. For this course, so this is very important. And if n is over 30, we'll say the distribution of sample means will be approximately normal. So everything over 30 is normal.
Okay, well that's easy enough to remember right there.
Yep.
There it is, right there. See. Okay, so anything greater than when n is greater than 30, just normal.
Yep.
So 4 is normal.
4 normal distribution, normal.
5, let's see.
Normal.
All right, normal. All right. So, that wasn't too bad. We're almost halfway through, it looks like.
Yep.
Yeah. Okay.
When will the distribution be normal distribution? All right, I just read that paragraph. So 2 conditions. Parent size, parent is normal or size is large. 2. First one says population is normal, distributed, size is small, that will make it. Same thing, but size is large. So
Yep.
definitely normal.
Normal. Yep. So it's already normal. And then third one, that wouldn't be it because you're right skewed, but because you're taking that small sample size, it's not going to be normally distributed.
Yep. Okay. No, it won't. I'll give the best explanation of central limit theorem. I don't know. No, what is that? Actually, I do.
And that's the bottom one there. If the sample size is large, the shape of the distribution of sample means will be approximately normal.
Oh, that's what it means.
That's what I picked for my answer earlier. It's when you get to question, was it 8? It says out there is question 9. Where I have to start doing all this stuff. Mean distribution of the sample means. That's where I'm like, I have no idea.
Okay, so what is number 8? What answer do you get?
If the sample size is large, so it's the bottom one. So if the sample size is large, the shape of the distribution of sample means will be approximately normal.
Okay. Alright, that big X would be a random variable of population mean, and then it is suppose the sample size blah and draw from the population. The mean distribution of sample means. Isn't that just reading the question? Isn't that the answer from the question?
And see, that's what I'm trying to figure out. What the heck is it saying? Distribution of sample means. Okay, so it's got a population mean is 10, so that's right in the middle. Okay, the standard deviation is 6. So it takes it 16 to 4. And then the sample size, so the total size is 36. This doesn't know on this histogram how exactly they would draw that. Notes again.
Okay, so here's the law of large number. It states that as the sample size, which is n, is greater, the sample mean will get closer to the population mean, which is the weird u, the strange u that we have right here. 36 at here consider a large sample in this course.
Mm-hmm.
The answer should be 10.
Okay. Does it mean?
Because I don't know how to calculate this. That's the thing. I don't know how to calculate this.
Okay, it's looking for the What is the mean of the distribution? Mean.
That one you can calculate by using the formula sigma. Yeah, sigma divide square root of n size. Divide by 6, that's 1. 10 is 1.
Okay, so get that right.
Number 9 should be 10, I'm guessing.
Okay, let me
I don't see
pull my calculator.
any.
Okay.
I don't see.
Okay, so we've got sigma, which is 6. So 6 by parentheses square root of n, which is 36. 1. So I got 1 as well. Because and that's using that 6.
Yep, that's the answer. And for 9 will be questionable. We'll see if 10 is right. Number 11. Regardless the distribution of population, if the sample size is larger than 30, what will it be shape distribution? Normal.
Yeah.
What theory will justify the last question?
The law of large numbers, right?
Yep.
Okay, so
Wait. Oh yeah.
okay. So for question 9, we have 1 as our answer.
No, that's 10.
Okay, so question 9 is 10.
Oh, wait. What is the mean of distribution of sample means?
That's the sigma over n.
Okay. No. Sigma over n is standard distribution means. So, the first bullet point. The distribution of sample mean is all possible x, the whole thing. No, sorry, x of the particular sample size. It has a mean of U and standard distribution. Okay, so summaries in number 7 summary of the textbook, it basically tells us the answer. So it says population equals the mean of the sample that you have. Basically the answer. And the standard deviation of your sample is sigma over square root n. So 9, I'm pretty sure is 10 because that's the population mean. And number 10 is 1 because the formula is what it gives for standard deviation for the sample. So
okay.
Do you want me to submit this and see if we got it right?
Yeah, you go ahead, submit, and then if we'll go, and then I'll submit.
Let me see. Don't just wait. Give me a second.
Yeah, that's right.
Right. Got 2. How many do we got wrong? So we got the last question wrong. And question number 7, we are missing 1 question. No, we're missing 1 choice.
Okay. So question 7 and 12.
And 12. So 12 is central limit theorem. That's what I was trying to guess.
And what did you mark the first time for 7?
It's the first 2. So
you had the first 2, and that was wrong.
That was 0.75 point. So we're missing 1 question.
So I'm wondering if it's the bottom one. So because you have a large size, so even though it's skewed, because your sample size is large, it makes it normal.
Oh yeah, that's right. That should be the one that should be marked. Do you want to try that and see if we got it right?
Okay, so I'll check that one. So I have A, B, and D, and then central limit theorem. And okay. Let's see. What the? Okay. It says I already submitted. Oh, I have one in progress. weird. Apparently, you didn't think I had finished it. I'll come back to this. Try again.
It's okay. I didn't touch anything. You should. If you need the answer again, I can give you the answer again.
Come on, computer. Come on, internet. Okay, so A, true, true. Okay, so go ahead and run me through it. What you've got. So,
All right. 3. 3 screw right.
Mhm.
4 normal.
Mhm.
5 normal. 6 normal. 7 is supposed to be data from the population that size is small, and the same thing but it's large, both correct, and the data drawn from population that's right school and sample size is large.
Yep.
Those 3 should be marked. Number 8, if sample size is large, shape of distribution sample means will be approximately normal. That's the answer.
Okay.
Number 9 is 10. Number 10 is 1.
11 was
11. 10 is 1. 11 is normal. 12 is central limit theorem.
yeah, that's right. There we go. Yep, that was it.
Let me do mine again. See how get this right. Yay. Nice. True, true. Question number 3, screw right. Normal, 5, normal, 6, normal, 7, 1, 2, 3. Last one. Yeah, memorize the answer.
Yeah.
It's not too hard. 1 and number 11. What is that?
Normal.
Normal. 12 is the last one. Central. All response saved. Submit quiz. Ding, ding. That is the 100%.
Woo!
Yay! This just a simple concept, not super hard.
Yep. Nice.
So we speed this up pretty fast. Yeah.
So we'll see how this will work on Thursday, because I know the whole career fair going on here. I don't know.
Do you want to just finish that at the same time right now? Because
I got bounce.
You got something else to do?
Yeah, I've got some more stuff to do. I gotta go. I don't know it'll depend on what time the information sessions are for the businesses.
Okay.
I'm okay if we need to meet later at 8.
What?
I'm okay if we need to meet later at 8 on Thursday.
I mean, I can do that.
So, like I said, I really won't know until the career fair, because they don't have any information posted yet on what time the companies are doing their information sessions. So I know you do it like at 5 and at 6. I just don't know if there's any companies that are doing theirs at 7. That's really kind of what I'm waiting for.
Oh, I see.
So if none of them are doing it that late, then we'll be okay. If not, we can try for 8. I just haven't looked at anything. I've got more stuff I got to do tonight, places I need to go run to, some errands to go and run. So.
Cool. Yeah, I'll let you go. I mean,
Yeah.
It's not a rush.
I'll go take a look. I'll try to open up the quiz though before Thursday, and at least look at the questions. So that way, if we do get on later, it won't take so long. So.
Yeah, that's a really good way to do it.
Yeah.
I mean, we're really efficient today.
Yeah, it was good. So it's nice it was a shorter one, but we did good either way. Okay. I'll go stop the broadcast and